So, exercise 1. The card is drawn from a standard deck of cards. What is the probability that the card is a queen, given that it is red? Yes.
I just have a question how you phrase that. Like, are you saying that like we know that it's only 26 cards if we both ones? Because or like are we just saying that it's a red queen? You know what I mean?
If the card is queen and you are told that it is red. So
like, are you drawing it from just red cards or from like a regular deck of cards?
you are drawing it from a regular, you draw it from a regular deck of cards. Just like we are playing cards.
Yeah.
And then by some mean, you are able to know my card is red. So given that this is red, you know that my card is red. What is the probability that that red card is a queen? That's why we call it conditional probability. That is, an information is known ahead. For example, you might see a female star, and you want to know what is the probability that that female star is a dean, or what is the probability that female star, you already know that she is here by some means, maybe just by hearing the voice. So that is it with conditional probability. Conditional probability, that is a condition is given to you. On TV, you have games like that, that they may give you some hints. Once you are given some hint, it reduces the information you really need to acquire. So I want you as well to understand the difference between the conditional and the and. If it was and, green and red, then we will say 2 over 52, because you are picking 2 cards out of 52. Now this card is picked out of 52, but you don't know whether it's a queen, yet you know it is red. Okay. A box contains 10 red balls, 6 blue balls, and 4 green balls. 5 balls are randomly selected from the box. What is the probability that exactly 3 of the balls are blue? So exactly 3 are blue will be the number of selection with exactly 3 blues divided by the number of selection of 5 balls. So the number of selection of 5 balls is 17 combination 5, because there are 17 balls in the box. The number of selection with 3 blue is taking the 3 out of the 6 and the 2 out of those balls that are not blue, which are 11. So if the problem, for example, was to choose 7 balls at random, and I ask what is the probability that 2 are blue, 2 are red, and 3 are green, then you have to do how many are red, how many are blue, how many are green, and multiply. Here it is simpler. You have 1 blue and then 2 the other one. 3 blue, 2 the other one. If it was 1, 2 is red, then 2 is blue, then 1 is green. Then you have to be thinking 2 red out of 7, 2 blue out of 3, 1 green out of 4. And then you multiply. This is the multiplication rule, involving combination at the same time. So in this case, we will have 6 combination 3 times 11 combination 2, which is 20 times 55. Because we need 5 balls. 3 are blue, so 2 are not blue. Now, how many balls are not blue? 11. Any 2 that you pick out of there will do it. Okay? Question? dice are rolled, what is the probability that the sum is less than 7? So we will identify the two numbers that could be less than 7. So an easy way to do that is to make a diagram, which we call a Cartesian product. If I say the sum, I can put plus here. It could be the product. Then I will write all the sums. 2, 3, 4, 5, 6, 7, 3, 4, 5, 6, 7, 8. I'm just adding the two numbers. 3 plus 1, 4. 3 plus 2, 5. 4 plus 1, 5. 4 plus 2, 6. These are the numbers. So now we wanted the probability that the sum is what? Is less than 7. So we have this. So we count the number of sums that are less than 7. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That is, here we have 5, 6, 7. Let's just count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So the answer will be 15 out of 36. We already know that there are 36 of them. By 3, this is 5 and 6. I'm sorry. So question 4. At a particular school with 100 students, 34 play football, 23 basketball, and 7 play both. What is the probability that a randomly selected student plays neither sport? So how many play football? How many play basketball? 20? 23. So how many play football and basketball? Remember that neither is the opposite of all, right? We know that, right? Neither is the opposite of all. So we are going to say that the number of neither have no basketball is total minus the number of football or basketball. Now the number for football or basketball is number for football plus number for basketball minus number of football and basketball. Yes. If you think about the addition rule as we learn in class, we say that the number of in A or B is the number in A plus the number in B minus the number in A and B. Just take it that way. So if somebody tells you that there are 25 students playing, there are 5 students in this class maybe playing soccer. And then there are 5 also maybe playing volleyball. Will you just assume that the number of students who play either of the sports is 10? And you know the number of, if you put them together, how many there will be? Yes. How would you have said it if you were to say it?
I would say it's either exclusive so it shows that the 7th either included or the top, like in the popular number already, or the basketball.
Can you say the problem the way you would have liked it to be? Do you have it? So no, you might say that SAT 205 class has 25 students, biology 201 has 30 students, and there are 3 that are in both classes. You don't want to say that when I say there are 3 that are in both classes, it means those 3 were not counted in the 25. That means I didn't give the correct number of students in the class. The 7 is included. All what we are saying is that how many people are playing football? Is that correct? That 34 students are playing football?
Yeah.
Yes. So that is how you should take it. Okay. 34 students, and let me complete the number. 34 students are playing football. That's what we do. If they ask the football coach, how many students play football? 34. Ask the basketball coach, how many students are playing basketball? 23. Now, the athletic director will know that of those, there are some that are playing both, and there are 7 of them. That's the key information. Otherwise, you can never know how many play football or basketball. Right? Yes.
When you were just explaining it, you said of those students. Could you put that in the problem? Like you say 34 play football and 23 play basketball. Of those students, 7 play those sports.
No, we are complicating it because of the reasoning you have after. We are making it easier. How many students are in, let's say, how many students are in SAT 205? I will say 20 students. How many students are in BAU 101? I will say 23 students. So if somebody knows how many are in both, so when you want to know the number of students in this class, you don't want to exclude any student that is in another class. How are we going to get it? Because some are in history, some are in. So are we going to say, of those 24, 2 are in history? Let's say, on those 34 playing football, 7 play basketball, 10 play volleyball, and do we need to say all of that? We only need to know how many students are in football, how many students are in basketball, how many students are in. Yes.
I'm just confused why the vote is important for how we're asking for categories that they don't play sports. So like, why is like the 7 even important if it's just 34 plus 23 for how many athletes play sports?
Because if you don't know how many are in both, you will never know how many are there in both.
Well, wouldn't we, because we're saying that 7 of those people are included in the 34, and 7 are included in the 23. Well, it's still just 34 plus 23. We know that they're in a sport. Like,
how many are playing the both sports?
then you would have 14 of them.
We already
Adding
know
the
this.
7 twice.
That's what I said, when you said no. Because I said we were supposed to add the 7.
Suppose these are the football players. These are the basketball players. Okay? How many football players do we have? 34. We don't need to say, not counting those who are playing basketball. How many play football? 34. Coach of football does not really want to know what sport do you play as before I give the number of students that play football. Do we get that? If somebody asks me how many students I don't care which other class you are taking. I know I have 20 students in my class. If I ask my colleague, how many students in your class? 20. They might be the same students, but that class still have 20. Imagine that all those who play football also play basketball. What are we going to say? 20 students play football, 20 students play basketball, right? How many does not play any sport? Will we say total minus 40? Think about it that way. Suppose all the students playing football are also playing basketball. Should the basketball player say, I have no student for basketball because all of them are playing football? Are we getting this? We can say that 20 students play football, 20 students play basketball, and all play both. If you don't know the both, you can never make the sum. If you are inviting to the party all the students from 2 clubs on campus, and you want to know the number of people that are going to be at your party, you really need to know. It's very important to know how many are in both. Do we get this? This is the formula. We have this additional rule. You would have just talked about additional rule. The neither was just for me to make sure that you know what is the opposite of all. Do we know that the opposite of all is neither? You use that, right? When you say neither, no, it is the opposite of all. So this is where it comes in. Neither sport, neither football, nor basketball. The work you have to do here is to knowing the complement rule for opposites and knowing the additional. So the additional rule is this one. This is the additional. So whenever, let's say for this class, whenever we say or is inclusive, it is only when I say exclusive that you should pay attention. And what do we call exclusive? We divide it here as mutually exclusive events. Do you remember that term? Mutually exclusive. I know that you are a little bit concerned because you are used to knowing that people should say or is inclusive or exclusive. But we took care of that by defining mutually exclusive events. If we don't say that events are mutually exclusive, don't take it that they are mutually exclusive. Otherwise, you are going to get into trouble because you are going to add the and twice. We don't want to add it twice. So 7 is here. 7 is here. And we're 34. We want to know now how many are here. That is how many play football without playing basketball. How many? 27. And how many are here? 60. So this is how you will distribute it. So that's why we need to say both. There is no other way to say both. So we are learning, okay? So we learn the language first. And then we use that language to work. If we don't learn the language, we are going to get confused when we want to work. Those who got it right will be arguing also that why did you say that 7 is not counted in? Okay, Suppose I say 60 play football and 50 play basketball. How many play neither sport? Are we getting my question now? Suppose I said 60 play football, 50 play basketball. Will that make sense? Is it possible that 60 play football and 50 play basketball? Okay. Now if I say, and 7 play both, will that work? Are you getting what I'm doing here? There are 100, 60 play football, 50 play basketball. At least how many should be in both? Somebody should think. At least how many should be in both? At least 10 should be in both. Let's say even 11, right? For it to work. So we need both. Both is very important. Okay, so we have learned this now. We are prepared for the exam. So let's go to the next question. Yeah, it was very easy, the answer. So next question, I have completed the table because I didn't want to spend the time doing that here. Almost everybody completed this table. Let's say that in an exam, I will give you a similar type of table and you will have to complete it. Now the question will be, find the probability that the patent is made in the United States and it was issued to the government. Now we have "and" here, United States and government. So this is where we are. If you were confused about giving that, this problem will help us ask a question. Why did you not choose the total of government? It's United States and government. Why are you dividing it over United States instead of government? Okay. I'm just helping how you can be reasonable. So probability is always over all, except when a condition is given. Do we get that? If you don't see given that, so you look at the next question, assuming that no question again for that. Given that the patent was issued to the government, given that, now you are going to divide by government. Okay? You see why I asked you, why did you choose? So, given that it was issued to the government, then you will divide by the government. Without writing all this, this is what happens. If you give me 900 over 100,000, put equal to 0.09. It's nice. We'll do that because it's simple to get that.
But if we didn't write something before that,
If you don't write this one,
yeah.
you just get this one. If you get it right, you will get your point. But when you get it wrong, you lose all points. Are we getting what I'm saying here? Because no room to give you any point. So if you had said here that this one is equal to United States and government divided by government, you got it wrong. But this one, which you did right, by writing wrong, gives you some points. Are we getting what I'm trying to say here? So that's why I encourage you to write a little bit. But if you are sure, no problem. You will get the point. Now, what is the probability that a patent was either made in a foreign country or was issued to the government? We are dealing with addition rule again here. So here we want foreign or government. Is foreign plus government minus foreign and government. Is that good? You will have this on Canvas. You know that it is already on Canvas. But I understand if you like to write, because when you write, you understand better. But I also want you, if you just feel like you can forget, even if you forget, go back to Canvas, it will be there. I'm going to put all the answers as soon as we are done. Okay, next question. In a small college, it is known that 80% of students have a smartphone. 3 of the students are randomly selected. What is the probability that all 3 have a smartphone? Remember, independent events, we just multiply through. None has a smartphone. You think about the complement first. Having a smartphone, 80%. Not having a smartphone, 20%. And then at least one of them has a smartphone. You do 1 minus none. For C, at least one, the opposite is none. And that none was the answer to B. Mm-hmm. Mm-hmm.
So like in the college, if it's 80% of the students have a smartphone, and the probability that like one of the students have a smartphone, isn't that just 80?
We didn't say exactly one. At least one. So it could be 2. It could be 3. So you can do, what is the probability that one has? If you say exactly 1, then out of 3, you should also know that 2 did not have. And that will be taken into account. That actually takes us to binomial distribution already. So you have 3 people. Just like we were selecting balls. You have 3 people. What's the probability that exactly 1 has a smartphone? Is the probability that 1 has and the other 2 don't have. That makes sense to everybody. If you have 3, for exactly 1 to have, it is not just for you to know that 1 has, it is also the other 2 don't have, for it to be exactly 1. Then you will do again for exactly 2. Exactly 2 will be the first don't have, the second and the third have. The first half, the second don't have, the third half, and all that. It will be more complicated to handle it one by one. That is what takes us to chapter 5, where we are learning about the binomial distribution. But before getting to the binomial distribution, at this point, we can know that if it is complicated to get the answer for at least 1, I will take the opposite of at least 1. And the opposite of at least 1 is what? None. And you have that answer in B. Okay. Still not very clear to you?
No, because like we're not asking if it's exactly 1 or exactly 2. We asked if at least one of them
at least 1 out of 3, what are the possible values when you say, I have at least 1, 2, or 3? So you can't answer it just once, because it can either be 1 or 2 or 3. So you will have more 3 things to take care of. You understand that? It means that the probability that is 1 or the probability that is 2, it cannot be 1 and 2 at the same time. You will get that. It's mutually exclusive. So it's either 1 or it is 2 or it is 3. If you want to break it down that way, you will have to find the probability that it is 1 and find the probability that 2 have, find the probability that 3 have. But I want you at the same time to remember that when you say only 1 has, you should also know that the other 2, because they are 3, don't have that probability actually matter. If we pick only 1 and I said, what is the probability that a student selected at random has a smartphone? Then you will have words. It's. If I was selecting 1, get that very well. If I say a randomly selected student have a smartphone, that probability is what? 0.8. If a student is randomly selected, what is the probability that that student has a smartphone? That is the answer, 0.8. But if you take 3, it becomes more complicated. Okay? These questions are very important because it helps us to understand. If you don't understand, just ask. We will stay until 1:15. Oh, 12:15. Okay, we still have time. So now this is finished with chapter 4. I hope we are not going to take that much time. There is less controversy in chapter 5. There is a lot of controversies. So as we are moving to random variable, it will be much easier. You see, this is answers to take home 4. It is already available. Now I will make take home 5 available by clicking here. And then we can look at it. Hold on a minute, please. I think I did something. Only the same thing. Okay, this is better because I gave more explanation to this. So we have an urn that has 2 red and 3 blue. I think we did this last time. I explained without going into detail. So this one, we should assume we have taken care of it. So the probabilities are 1/10, 6/10, and 3/10. No red means red and red. I'm sorry, no blue means red and red. 1 blue means either blue and red or red and blue. Those are the type of things we are learning in this class. You are learning critical reasoning. So that's why when you have questions, feel free to ask. So the expectation or the mean, we call it expectation when we write E, or the mean, we write it also mu, is value times probability plus value times probability plus value times probability and so on. and add it up. Okay? Value times probability plus value times probability plus value times probability. We express it as x times p of x. So we have 1.2 here. Then the mean of the square is not the variance. It's useful in computing the variance, but it is not yet the variance. We square the values. So I like putting here x squared x squared will be 0, 1, 4. It is below, but it is the same probability because the same number was squared. Now, use square the squared value, which is below here, times the probability. That's what gives us the mean of the square. The mean of the square. That is 1.8. Then the variance is mean of the square minus square of the mean. We need to know where square comes. First, it is in the expectation. Second is out of the expectation. And that's what gives us 0.36, and the square root of it is the standard deviation, 0.6. Now, for the second problem, we have an item that with value 20,000. You pay $250 to secure it with your insurance company. So the revenue the insurance company has is what? The $250 you pay. How much are they going to spend? Depend on whether the item is lost or not. That is where the random variable is. So the probability that you will get lost is 0.002. Probability that it's not going to be lost is 1 minus 0.00. So that gives you these small probability distributions that you can find the expected revenue, the expected cost. How much do they expect to spend for that item? It will be 20,000 times 0.02 plus 0 times 0.998. That's what gives us the 40. So for that 20,000 value item, insurance company expects to spend $40. That's why they go into the business. So normally we could challenge them and say, why don't you just charge us $40? Because if you charge you $40, they will close their business. You need to think about many other things they might spend. They call you sometimes, they pay people to file and all of what can happen. And then they want to make profit and a lot of profit. People want to make a lot of profit in business. So the expected cost is $40. If you pay for $250, then the expected profit is $210. It's based on that people get into business. This is a nice application of mathematics in real life situation. So exercise 2. These are examples of transformation of random variable. The first one is a linear transformation. In a linear transformation like L equals to 2x minus 200, the mean is 2 times the mean minus 200. The variance is 2 squared times the variance. So that's how we get the 2 times 130 minus 200 equals to 260 minus 200 equals to 60. And 2 squared is 4. The variance is the square of the standard deviation. So 4 times 6 squared equals to 4 times 36 equals to 144. So the standard deviation is the square root of the variance, which is the square root of 144. Yes. From what point? You got the mean? Okay, good. So let's look at the variance. When is the linear transformation? In a linear transformation, you have only one x and another number has no x. So for mean, that number, you still take care of it. For variance, you forget about it because it was a constant. A constant does not vary, right? So the variance of a constant is always 0. So the square of 2 times the variance. Now the variance is the square of the standard deviation, and the standard deviation is 6. These 2 square, that's the formula. This is the formula. A squared times variance of x. The 200, the minus 200 for variance, only for variance, because it's a constant. It's a constant because there is no variable attached to it. Do you see that there is no variable attached to 200? The variance of a constant is 0. Makes sense, right? If it is constant, it means it's not changing. So we are left only with the variance of the value with x. So you square first and multiply. We can prove it, but it's mathematics, so I don't want to do mathematics here. No, not the variance here is the square of the standard deviation. You see here, this number, sigma x, that is the standard deviation of x. So we do 2 squared times the square of that number. Does that work for everybody? Everybody's okay with this? So times 6 squared. That 6 was the standard deviation. Do you see sigma there? Is the standard deviation. Variance is sigma squared. So each time you have the standard deviation, to find the variance, square the standard deviation. If you have the variance, to find the standard deviation, square root of the variance. Okay? Now, for the second part, you have what we call a linear combination of 2 random variables, because 2 variables are involved. 2 variables are involved. You square both terms. You see here, I'm sorry, for the mean, you do a linear. The mean is 3 mean of x minus 2 mean of y. That is the mean. The mean, almost everybody got the mean right. Problem is with the variance. Don't forget to square the 3. That is some of the mistake you made. Variance, square the standard deviation. So you square, you square. Square of A times square of the standard deviation. So the square of minus 2 take away the minus. So some of you did not square the minus 2. If you do, 3 minus 2 square is going to do 3 minus 4 on your calculator. Be careful with that. When you have a square and you are using your TI-83 calculator, use parentheses for minus. Otherwise, you will think that it's minus and then the square. Or you do it separately. So we have 9 times 6 squared plus 4 times 5 squared, which is 324 plus 100 equals to 424. You take the square root of that, it's 20.6. So in question 5, I will advise you to use the Google calculator. I solved like this because that is the formula that I taught you. But if you use the Google calculator, whenever you have binomial problems, binomial distribution calculator. So what was the probability of success? Anybody remember? 0.07. And the number of trials? 5. And x is 3, and I'm going to manipulate quotients about x. So when we say that x equals to 3, then we get 0.002966, which we all agree that is 0.003. So now the next question was x is greater than or equals to 3. When we say at least is greater than or equal to, then you get here. If you are grading, please help me. If you are grading, and on this last question, somebody gives you this answer, 0.029, is it correct? Pay attention to what I'm saying. If you see this answer, 0.0029, at this question, the last one, is it correct? It's not, right? Okay. So when I see that, I feel like, how did this student get this one? But if you say 0.003, I will not know. I will not know that you got it wrong. And if I put it you wrong here, you will quarrel me. Why you put this one right when he round up? It's not the round up that gets 0.003, right? It's kind of actually the round down. Are we getting what I'm saying here? So sometimes don't just compare your answer to somebody else's answer. You might not have done the same calculation to get to that same answer, but we are not showing calculation. So at this point, the 0.03 here is because you round it down. It's correct. The 0.003 up here is because you round it up. It's correct. But if you just see somebody doing it and think the answers are the same and write both sides the same, the other one, I will mark it wrong. Do we got what I'm trying to say here? Okay. So we have the answer to 2 questions here. So you don't have to solve it the way I did. Are we getting this? I am solving it the most difficult way. You can just write the answer, but write P of X or probability that at least 3 is 0.03. You are good. If you do this one, write that answer, you are good. If you like to do this one, no problem, but it might take you more time. Because I know you are using the Google calculator. The mean for a binomial distribution is n times p. 5 times 0.07. The variance is n times p times 1 minus p. That is the q that I'm putting here, which is 1 minus p as I put here. 5 times 0.07 times 0.93, giving you 0.3. Take the square root, 0.57. That's good. One minus, right? P is 0.07. 1 minus P, just like 7% or 93%. Failure is 93%. Success is 7%. Q is for failure. P is for success. If you still have questions, immediately after the class, I'm going to the office and it is office hour. We can still go over what you don't understand. A test score has a mean of 80 and a standard deviation of 4. Use the empirical rule. Estimate the probability that a randomly selected score is below 72. Standard deviation is 4. 72 is 80 minus 8, which is 2 standard deviation. So using the empirical rule, you are below the second standard deviation. What? For 6? You want to see the answer for 6? I'm going over it. I'll publish it when we finish. Okay? Yeah, what happened is that I published it in the other class where I picked their own take-home problem 5 where I made more explanation. I will put that one to YouTube and I will publish your own as well. So as we are going through, sometimes I add more information to it. Don't worry, when I get to my office, I'm going to fix everything. So, well, it doesn't take me that much time to do that. I can say I will do it later and I still forget. So if you normal distribution, 80, 1 standard deviation, 76, 72. 34% here, 13.5 here, and you are asked what is this? So 13.4 plus 34 is 47.5. Half of it is 50%. So 50 minus 47.5 is 2.5%. It's true that we know that within 3, you have 2.35 here, but we say below. Is that good? Find a z so that the area to the right of z is 0.7213. Because this area to the right is to the right, your calculator only use area to the left. So you will do 1 minus area to the right to get the area to the left. Area to the left of that value is 0.2787. Using your calculator with 0.2787, you get negative 0.587. When you have area to the right, subtract it from 1 before using it either on Excel or on your calculator. Find a z so that the area between minus z and z is 90%. Minus z and z is 90%. This is minus z. This is z. At the middle here, so you have 45% here and 45% here. So you have 5% here and 5% here. So you use 0.05 as the left area of minus z. Once you get the value of minus z, you know what z is. Which calculator do you have, TR83? just go to second function, distribution, inverse normal, and you type 0.05. Because it's standard, the calculator knows that the mean is 0 and the standard deviation is 1. Exercise 2. Mhm. Mhm.
We didn't have the tails 0.05. Like you have down the tails are 0.05.
Here, okay, I didn't write the tails are 0.05. Okay, I will check that and put it there. Okay. You know how to get the 0.05, right? That is what I wanted you to know. It's how to get 0.05 that you are solving this. So 0.05 is not part of the question. I don't tell you that the left tail is 0.05. You figure that out just as I show you now. So I want to show it again. This is, let me just, so this is a normal distribution. If you are given the area between minus z and z because of symmetry, this is minus z, this is z. So if this area is 90, then here is 45, and here is 45. So that's what tells you that here is 0.05. Question exercise 2. So in each of these exercises, you want to know what is the mean and what is the standard deviation. What is the mean here? And what is the standard deviation? What is this 5 doing here? X is a normal distribution with mean 6.7 and standard deviation 2.2. So you want to find the probability that X is between 6.4 and 7.2. You cannot learn this method now. This is what you should learn. Use normal CDF in your calculator. Can we all use that? If you cannot, ask and I will show you. Second function, variance for distribution, then normal CDF is normal CDF. Then if you have a parenthesis, you will enter lower value, upper value, mean, standard deviation. If you have a better calculator, that will tell you what is the lower value What is the upper value? What is the mean? What is the standard deviation? You apply it. And you get your answer, yes. .16. Yeah, it's correct. Because the calculator doesn't round up anything. So when you did manually, it might be a little slightly different. I do it manually because I'm the professor and I want to do this stricter expectation of what you should do. Then I show you your calculator so that you don't waste your time doing this manual calculation. You know, this class is going in pair with Math 215. So Math 215 is mathematics for science students, mathematics students. So they are expected to use mathematics. So that's why you see us. If you learn it, there's nothing wrong. Use your calculator. As we are going to move, you will be seeing some little discrepancy between calculator and the answer at the back of the book and the answer when you are doing manually. Because manually, you round up in order to go. And how you round up also depends on how close you get to the answer. Is everybody good with this one? Any question about this question? So I want to remind you, if it was greater than, you might not have the upper value. If it was less than, you might not have the lower value, which is actually minus infinity and plus infinity. And so just use minus 1 million and 1 million when you have that kind of question. We are going to have one. So next question. From long experience, it is known that the time it takes to do an oil change and lubrication job on a vehicle has a normal distribution with a mean of 17.8 minutes. And standard deviation, yes. Which problem? The one I'm reading or the one before? Okay. It should be 0.98. Where I can't see it here. Oh, okay. Change this one to 98. Okay. So what answer do you get? Is that what everybody gets? What do you get exactly? 28.48. So that's why I rounded up to 28.5. I just want you to see that that 2 was just a typing. It's not a way to count. If you put 92 there, you will not get that answer. So 20. If you give me 29, there's no problem. 29 will even be better. Who will say if you stay here 28.5 minutes, I will give you a free load? Do we get what I'm saying? And he might not want to give 28. Why? Because he wants to give to as less people as possible. Do you understand this problem? He is working on people's car and he does not want his customers to go because they overstay at his shop waiting. And he said, I want to give to anyone that stay too long a free loan. But too long will mean what? In the top 2%. That is the limit. So when you get an answer like 28 point something, don't say 28. It will be more than 2%. Are we getting what I'm saying here? If this is 2%, and you get here 28 point, let's say 0.5, 28 is more than 2%. So if you give 29, you are right. You are better than the one that gave 28. Sometimes it's just better to give me the number. It's true, I'm not that strict when I'm grading, but I want you to understand why Rounding up depends on what you are aiming at. Last exercise. Here, we want the mean and the standard deviation. The question here is about, because of time, I'm going directly to the question. What is the probability that the mean diameter X bar for these oranges is between 2.7 and 3.8? Because it's a mean diameter, you want to know what is the sample size for that mean. What is the sample size for this mean here? What is the sample size? 8. So you need to find this value, the new standard deviation. That's it. The standard deviation will change. You divide it by square root of 8. And you do the same thing that we did before. On the second part of the question is exactly the same thing, but is X bar is greater than or equal to 0.77. So you see, I put 177 as the lower value, and the upper value, I just put 10 raised to power 10. If you were put 1,000 or 1 million, it is okay. 1,000 will also be okay. It's more than 10 standard deviation. The standard deviation says 10 standard deviation is 320. But I don't want to give you 1,000 because you can have a problem with a large standard deviation. But you are sure that it's not going to be 1 million. Okay? We made it. So we have take-home problem 4, 5, 6. That is going to be on the exam. If for any reason you have a question, just send me an email. If I need to explain to you on Zoom, we will arrange for a time and go on.